Hello, ladies and gentlemen. Today we're going to be taking a look at functions. So what does it mean to be a function? For this, you're going to need your notes as well as something to write with. In Algebra 2, we're going to focus on more complex functions than you learned in Algebra 1. So beyond just lines and parabolas. But before we can go here, we need to know the basic understanding of what it even means to be a function. So when you hear the word function, and in that phrase above, on more complex functions, what does that word even mean? So our learning targets today, and please write these in your notes, are that you can state the domain of a relation, so you understand what the words domain and range mean, and that you can determine if a relation is in fact special, called a function, okay? So if it's a special one called a function, we need to be able to identify that as well. So in Algebra 1, you viewed functions sort of like a machine, where you had input values, and they were x values most of the time in your tables that you made, and you would plug them into some sort of rule or equation, and it would generate output values. Every x value generated an output y value, and then we grouped these together and made them into ordered pairs that we would then graph, say, to make a line. This set of ordered pairs is called a relation. So a relation is a special name for a set of ordered pairs. And in every relation, there is a domain, which are just the x values, and the range, which are the y values. So that little pencil right there says, you might want to write this part down in your notes. So it is a set of ordered pairs with a domain and range, or x values and y values. So when we look at ordered pairs, when we look at a relation, we want to know if it's special. That is it a special one that we can call a function? Does it have a function relationship? And to be a function, you have to go just beyond having x's and y's. You need to have special relationships between the x's and y's. So a function is a relation or a set of ordered points where each value in the domain is paired with exactly one range value. So each x is paired with exactly one y. Now, what does this exactly look like? A lot of times people have a hard time with this definition and understanding what to look for in a set of points. So let's think about some real life examples that you might be familiar with. Consider the vending machine, okay? Each vending machine has buttons on it, right? And each of these buttons will lead to an output value. So the buttons are like the input, and you have output values. That's the beverage that you get out, right? So in this example, or on this vending machine, both this button and this one right here, these two buttons, both lead to the same outcome. They both give me just regular plain water, okay? So this is okay. We can have one button, two buttons, both of them leading to the same output. But where we run into trouble is when you have a broken vending machine, right? Let's say you press this red Gatorade button and a red Gatorade comes out. But then behind you, your friend presses that same red Gatorade button and now a green tea comes out. This brings up the question, is it okay that that happened? Can one button lead to two different outputs? That's not okay, right? That person would complain, I wanted a red Gatorade and I got a green tea. I pressed this button and I did not get the output. So that is a situation where it's not a function, okay? Functions are every button leads to one output. But a broken function, or a non-function, if you will, means that that's not happening. So let's take a look at a couple other examples in real life here. A function relationship would be states and their capitals. Each state has only one capital. Okay, the state of North Dakota is only Bismarck. And the state of South Dakota, the capital is only Pierre. The state of Minnesota, just St. Paul. Whereas a non-function example, one that doesn't meet the definition of a function, would be states and their senators. There are multiple senators for each state, right? So North Dakota actually has 2 senators. And because each x being North Dakota, right, is paired with 2 different y values, that means that this is not a function. So let's look at what this looks like in terms of math, okay, or in terms of our set of ordered pairs or our points. So these examples need to get written in your notes. We're going to take a look first at a table. This table of values here we have ordered pairs written here, and we want to list the domain and range according to the directions up there, and then determine if it is a function, so if it meets that special definition. So the first thing we want to do then is list the domain and range. The domain is just a list of all these numbers here that are in the X column, and the range is a list of all the numbers that are in the Y column. So we're going to make a couple lists here. When you make a list though, keep in mind we want to list them in order, lowest to greatest, okay, least to greatest, and then we also want to make sure not to list any that are repeating. So my domain in this table includes the numbers 0, 1, 2, and 3. So I just made a list of them right down here. These little brackets here need to be there, okay? We're saying the domain is the set of just these numbers, okay? And then we close that little fancy bracket on the end as well. The range is listed in a similar way. Okay, be careful though, these y values, the smallest one is -7, so we're going to actually start our list with -7, and then the next smallest would be -4, and so on. So when we make a list of range values, this is what it looks like, the R for range, and then again, the little fancy brackets here need to be there. So we've listed the domain values, we've listed the range values, and now we need to go ahead and say whether or not this is a function. Is this a function? Is every x paired with just one y? This x is only paired with 2. The x value of 1 is only paired with -1. The x value of 2 is only paired with -4, and so on. So yes, this is a function. Let's look at another way to look at points. In a mapping diagram, it's called. So it's another way to show points, but it's not a table setup. This has an X column and a Y column, but the arrows show who's partnered with who, okay? So the 3 is partnered with the C and the 4 is partnered with the C. So if we were going to go ahead and write a list of domain and range again, the domain is all the X values in order. So the domain is 1, 2, 3, and 4. The range values include letters in this case, so we'll put them in alphabetical order. So the range is B, C, D in alphabetical order. Now, is this a function? Let's double check. Is each x paired with just one y? So this is an x value of 1. 1 is only paired with D. 1 doesn't have any other partners here, okay? And then 2 is only paired with B. 3 is only paired with C, and 4 is only paired with C. A lot of times people have a hard time with this right here, but remember we looked at the vending machine. This button and this button can both lead to the same outcome of water, right? There can be two different buttons that lead to water. We just want to be sure that the same button doesn't give two different outcomes. So this, in fact, is a function. Let's look at another mapping diagram here, one that isn't quite as nice here. We're going to go ahead and list again the domain and range. The domain is the x values and the range is the y's. And now to look to see if he's a function, we want to again look to make sure that each x is paired with only one y. Here's an x value of -8. He's paired with -6 and 1. This is not good, okay? This is like the button that leads to two different outcomes. Red Powerade button gave me both red Powerade and green tea. Not a good situation. So this is not a function. Not a function. So that's what we're looking for. Many times people like the mapping diagram to show that because you can see right away that that -8 has two different branches coming out of it, whereas all of these each have one branch over here coming out of them. So sometimes the mapping diagram is an easy way to see if it's a function. So for the last two examples here, we're going to go ahead and draw some mapping diagrams to kind of illustrate that point again. Here's the first set of points written in standard, point notation here, coordinate notation, and we're going to go ahead and make a mapping diagram of them. So I'm going to draw the two boxes. Now in the first one goes all the x values. So my x values here are -2, 1, or sorry, 0, 4, and 5. And if I put them in order, I would just place them in vertically here. And then my y values are 0.5, 2.5, 6.5, and another 2.5, but I'm not going to list it twice because you don't list repeats in a list, okay? And we're going to just list those y values there. And then we draw those connector arrows. So notice in my first point, -2 was partnered with 0.5. So I'm going to draw an arrow from -2 to 0.5. 0 was partnered with 2.5. 4 was partnered with 6.5. And 5 was partnered with 2.5. Now if we look through, we want to check and make sure each of these x values only has one branch coming out of it. Okay, each x is only paired with one y. This one's paired with one y. This one's paired with one y. This one's paired with one. Only one path, right? That's what we're looking for. So that is going to be a function. So we'll list the domain values, we'll list the range values, domain and range, and then we'll go ahead and say yes, it is a function. Now let's take a look at the last example here in your notes. Again, let's draw a mapping diagram to kind of illustrate how cool that is in order to see the relationship happen if you're a visual learner. We'll go ahead and place the x values in. I have an x value of 6. I have one of 4. I have another 6, but I'm only going to list 6 once. And then I have a 5. So when I go ahead and make my list, notice that 6 only appears one time. And then I'll list my y values. And then we go ahead and draw the connector arrows. Okay, 6 goes with 5 is the first point up here. So I'm going to go ahead and draw 6 going with 5, 4 with 3, 6 with 4, and 5 with 8. And you can see, again, here's our problem, right? 6 has 2 branches coming out from it. That's not good. That's one button leading to 2 different outcomes. So this one's not a function. But we'll still list the domain and the range. And then we'll say, nope, it is not a function. Okay, I hope this lesson helped review a little bit of those key words so that we can proceed forward in Algebra 2. Thank you very much for taking good notes, ladies and gentlemen.